Thank you. Thank you all for coming. We'll talk a bit about Scala and Bazel, using and developing with Scala through 3 different user stories. We start off with Wix.com. So my name is Ittai Zeidman. I'm one of the backend engineering leads at Wix. And I'm currently building Wix's next generation build system. Of course, heavily based on Bazel. So just to get you into the context of Wix.com, we have around 500 developers. Our backend is mainly Java and Scala, and our frontend is mainly React and Angular. And we have around 4,000 build jobs, which translate to roughly 25,000 build runs a day. Now, our problem was we started out by frustrated developers with local build times. So we had a few repositories with medium to large size, a few hundred Maven modules, a few 100,000 lines of code, and ever-increasing build times. But we quickly realized that CI is much worse off. So we are using Bazel's paradigm in dependency at head, but using it with Maven and binary dependency and snapshot and TeamCity, and building a whole kind of tooling to try and stitch things together and try and keep it up at scale. And that's not a really good experience. So we very quickly understood that what we need is to see how this story evolves throughout the whole layers. Where are we now? We automatically migrated our first backend project. Now, this is completely automatically, OK? 200 Maven modules, around 200,000 lines of code, migrated to 1,500 Bazel targets. This is almost source package granularity, completely automatically, using an internal tool that we'll touch in a second. We saw on average on developer machines a savings of 90% of build time. This is actually, by the way, without paralyzing our end-to-end tests because of some sandboxing issues and Mac OS, virtualization, so on and so on, if you're familiar with the tickets. But we're also hoping to save that. And we're just now migrating a few more projects, and hopefully in the very near future, we'll be migrating all of the projects. So how does this magical unicorn migration work? So we start off getting some repository, and we analyze what modules it has and what dependencies it has using Ether. We then try to understand the external dependencies. So we go to the organization's source of truth, right? Usually, organizations have that place that says Guava is 19 and Net is 4 and whatever and whatever. And we understand that transitive graph. And we take those 2 realizations, and we output third-party build files and update the workspace file. In parallel, we understand the internal build graph. So we work with a company called Codota, and they get our source code and our bytecode from our existing Maven build. And we create that API to get the code graph. We do a whole transformation to convert it into a target graph. So we basically take the files and we aggregate them into packages, and then we get that cyclic graph and get all the strongly connected components, and we get a DAG, because of course packages have cyclic dependencies. That won't surprise any of you. By the way, the label syntax in Bazel is pretty loose, so we are able to denote such a case with just saying name equals AGG. So aggregator equals something plus something plus something. So it's very easy for a developer to know, hey, OK, there is a smell here. This is a cyclic. So we transform that into a target graph, and then we, of course, output all of the relevant build files. So this is important to say this supports all scopes. So Maven scopes, test scope provided, and whatever is needed. Another thing that we've built, which I think has been talked recently in the community, is our synchronizer. So let's say that you have an update in the source of truth of the organization. Someone upgraded the Guava version. Now you want this to propagate to all of the Bazel repositories, or even to the Maven repository the Bazel repository to be synced with the Maven ones if you're in migration period. So we have a service that listens to the change, understands the transitive graph diff using the resolver from before, checks out all of the organization's repositories, and outputs to the workspace and the third-party build files the diff. So that way, they're all kept in sync. What we don't have now, and we will need to add, is a way to add overrides. Oh, I forgot to add actually that in the migration, the migrator has a lot of overrides capabilities, so that if you have false negatives or false positives about testing and so on, then users can tweak the migrator. We need to add some tweaking to the synchronizer because, like many of you have already been feeling, the one version policy is really, really good to strive at, but there are rough edges. So this is a bit about our user story. I'd like to take you now into a few of my favorite Ru Scala tidbits. And we'll start with the JVM interoperability. Now, it might be surprising for some of you, but this snippet of a Java library, depending on a Scala library, wasn't really an option up until a few months ago. So mainly because Java library is a native rule, and there wasn't a good protocol to say what outputs, what inputs does it expect from other rules, and so it just had a very strict subset of rules that it could depend on. And what we did was to have deploy jars generated from Scala library, which meant class path pollution, and so on and so on. So the main parts were, of course, providers, declared providers, and in this case, Java Common. And I really want to take this opportunity to give props to the Bazel team for identifying this gap, designing it, and iterating with us until we've closed the loop. So really, thank you very much. You know who you are, so thank you. If you want to implement such an integration in your own rules, the important parts for us are, of course, Java info. That is to grab the provider from your dependencies so that you know what they expose. To create a provider so that others can depend on you. You know what are your compile time dependencies, transitive compile dependencies, runtime dependencies, and so on. And also, might take advantage of Java Common Compile. This was very important for us because for us at Wix, we have some packages that have cyclic dependency inside of them between the Java and the Scala sources. And that meant that we needed Scala library to be able to compile both Java and Scala. We used to do that just by spinning up Java-C. And that didn't respect Java toolchain and a whole kind of other things. So again, this is thanks to the Bazel team. We use Java Common Compile and are very, very happy with it. Next up, testing support. So we at Wix.com are really big fans of testing. And I'm glad to say that Uru Scala supports the big three libraries, Scala Test, JUnit, and Spex2 via JUnit. And we're thinking about adding support for Spex2 native also. And the cherry on the top, for me at least, is the Maven-like test discovery feature. So if you can see, you can specify prefixes or suffixes on the target. And that will discover, like in Maven, all the classes. Note, not the files, but the classes, because in Scala you can have many classes in the same file, which end or begin with these prefixes. For us, this was a really big blocker because we often have packages with, let's say, 10 files, but 15 classes. And Oscar told me that Scala Test just automatically discovers them. So in JUnit and Spex2, this does not happen. Last but not least, strict deps. So I'm guessing many of you know what strict deps is. But just for those of you who don't know, strict deps is about prohibiting transitive compile time access. Okay, so let's say in Maven, if you have A, which depends on B, which depends on C, then in the code, A can also depend on C. Now, this can really, really come to hairy places when B does a refactor, stop using C, and then pushes and A breaks. And oh, what are you doing? Revert, you broke my build. So fortunately, Bazel really tries to push you off that path. Now, what we had in Rule Scala up until, or even in master still, is that there are cryptic errors. Okay, if A depends on C, there is some cryptic error by Scala C, and you're now left to handle it. Strict depth tries to give you this premise, but with higher level action. How does this look? So you specify minus strict depth equals error or warn. You build, of course, your target, let's say A in our case, and then you get an error that says C is used but isn't explicitly declared. So you actually have a warning that you can understand. And the bonus is if you have Bulldozer installed, you can just apply this, you can just copy-paste this line, and it will just add this dependency in the build files. So by the way, there is also an open ticket for Bazel Watcher, if you're familiar with it, iBazel, to automatically apply this. So parse those Bulldozer and just automatically apply those. So basically, in development mode, you can work with warn and have rapid feedback. And on CI, you can have error, and you can have that checked out. Now, getting this to work included quite a few details. We need to write a Scala compiler plugin. We needed to propagate the labels. So you see that it says that there is C as a label dependency, but this isn't part of Java Info. I hope to get it in Java Info soon, but we needed to collect those and pass them on as attributes. This is why, by the way, this won't work with a lot of the existing rules, but it does work with Scala rules and Scala import. So you get the, by the way, if you use the other rules, you would just get incoherent labels. It will still work, but the call to action will be less valuable. We need to propagate transitive compile jars, which did get into Java Info and saved us a lot of code. Expose strict depth flag to Skylark, and do the Bulldozer integration. So this, again, required a lot of iterations with the Bazel team, and they were really, really helpful, especially Irina. So thank you very much. And I'll give the stage to Ahir now. Thank you.
Can you hear me? Okay, cool. All right. So hi, yeah, my name is Ahir Reddy. I am the tech lead of the developer tooling team at Databricks. We're a team of about 4 engineers, and I've sort of been at Databricks for about 4 years. So about Databricks, we're about 80 engineers based in San Francisco. The short version is we do Spark. So we're created by, we were founded by the team that started Spark at the AMP Lab at Berkeley, and what we work on now is delivering Spark in the cloud. Cool. So a little bit about the build at Databricks. We, from the beginning, have settled on a monorepo. A lot of former Googlers were around at the beginning, and they showed us that this was the one true way, and it sort of has worked out quite well. And today, everything is built with Bazel. So about 500,000 lines of Scala, 150,000 lines of JavaScript. You'll see there Java. We build all of our services used into Docker containers, and many more languages: Python, Go, JSONnet, and we even use Bazel to manage our deployments and configuration. So kind of a chart. I don't know how easily readable this is, but you can just see over time code growth. So the green is build files and Skylark. So you'll see that's when that PR merged that month, and it sort of has grown over time. So, all right, so where were we before Bazel? So we've been around for 4 years, and Bazel wasn't an option when we started. So we previously used SBT, or the simple build tool. For those of you who aren't familiar, it's the sort of standard in the Scala community. It's designed to compile Scala and Java. And we extended it with custom tasks for JavaScript, Docker, and Python compilation. So while SBT is a nice enough tool for small projects, it's not exactly designed to handle a monorepository. So what we observed as we scaled scaled SBT was about 20 seconds of overhead. So when I say no op compiles, I mean SBT decides it has nothing to do. That takes about 20 seconds. And that really wasn't acceptable. And what was actually as big of a problem was the fact that it was completely unmaintainable in terms of the complexity. So other than a couple of folks who enjoyed working with the build and sort of became in-house SBT experts, no one else could really touch it. It was pretty impenetrable. And around testing, it didn't really have great guarantees. So it was slow and unsandboxed. So you'd have a lot of leaking between tests, writing files, temporary directories, all that sad stuff. So in the summer of 2016, we decided to make the transition. We'd experimented with Bazel sort of towards the end of 2015 and sort of realized it was viable. And we sort of waited, see if like there was a community growing around it, and there was. So we kicked off the migration. So at the time, we had about 90 sub-projects in SBT. For some context, projects in SBT tend to be quite large because there's a high cost to adding a new one. So this amounted to about a roughly like 300,000 lines of Scala. And of that, 15,000 lines was just SBT build definition. So one thing we determined early on was that it was too large and too risky to convert this in a single pass. So what we did was we maintained a parallel SBT and Bazel build for the duration of this migration. And that wasn't very fun. Development and projects were moving quite quickly during that time. So it was really difficult to keep up with changes in the SBT build. So what did we do? Well, we automated it. So we wrote an SBT plugin that would convert the project into Bazel. So what would it do? Well, it would traverse the SBT project graph and convert it into a Scala graph. So we used the wonderful open source Scala build rules, and we just emitted the various targets that we needed. So we'd traverse the graph, emit library targets. In order to find tests, we would perform compilation, do test discovery, and emit Scala test targets. And we also had to handle Maven dependency resolution that SBT, like Maven, takes care of. So we had two modes for this. Initially, we would directly resolve dependencies and just check them in. Later on, we emitted a JSON representation of the Maven coordinates and built a tool to take that representation and convert it into a set of build files. So what did this let us do? We could maintain the parallel builds without too much overhead. We told people, hey, there's this new Bazel thing, go ahead and try it. We think it'll give you a lot of speed up and you'll get much better error messages. So when things didn't work, people would fall back to SBT. And over the course of the next 4 months, we incrementally added the features that we needed, squashed bugs in our Bazel build, and all while keeping SBT as the source of truth. And once we were very confident, we would remove one sub-project at a time. I think around this point, we had grown to about 110 sub-projects. And one at a time, we'd remove them until nothing was left. So one note, if people are interested in this SBT plugin, feel free to just reach out to me, or I'll just be hanging around after, and we'll open source it if there's interest. So that sort of brings us to today. What do we have now? We have about 900 Scala targets in Bazel. They actually they target multiple Scala versions, 210, 211, and 212. In some cases, there's the same set of code compiled across all of these versions. And we also have about 2,000 Scala test targets. And here, the sandboxing and parallel execution has greatly improved both the test speed and the stability of tests. So our CI has been much more green than before. And like I mentioned before, we now have a dependency management tool to take a set of Maven coordinates and map it into a graph of build files. So this way, we've sort of baked in or snapshot our dependencies and just check them in. So source control is the source of truth. There are no external dependencies at build time. And lastly, some recent work. We've developed a little bit of automated tooling to split up large projects. So one sort of artifact of the migration from SBT is we had very large individual projects, sometimes some projects are like 20 to 30,000 lines of code. These compile as one artifact. So when you're doing iterative development, a 30-second compile cycle isn't that pleasant. So we built a little bit of tooling to break down targets, describe them as a sort of graph of related classes, and wrote a module to consume that graph, run some bulldozer commands, and generate a bunch of small targets. So we could automatically-ish break up large projects into smaller ones. So to conclude, at Databricks, we love Bazel. We've been very happy with the migration. I think the key thing besides performance and stability is that it's gone a long way in democratizing our build. So many engineers feel comfortable writing their own rules and macros, in addition to being able to debug issues with the rules or with rules that they use today. And Bazel has provided us with a lot of other test benefits. Bazel's strong caching and isolation model has let us do things like selective test running. So it's very easy for us via Bazel query to do things like only run the set of tests that a patch, CL, pull request, whatever you call them, to only run the set of tests that they affect. This has greatly sped up test times and stability. So this is something that we think is pretty important in a monorepo. You probably don't want to run that guy's tests that are flaky and broken if your change doesn't affect it. And lastly, we've done a lot of work around integrating our build with Docker and Kubernetes. So from our perspective, configuration is just code with dependencies. So pushing a new configuration amounts to building that configuration, which compiles all the necessary artifacts and lets us sort of in one step build and push that configuration to Kubernetes. So Bazel made this super easy. Check out my colleague Miles' talk tomorrow, and Matthew's talk tomorrow. They'll sort of dive into this a bit more. And I'll hand it off to Oscar now. Thank you very much.
Hello. Okay. Let's see. I'm Oscar Boykin. I'm at Stripe. I'm an engineer on, unlike these guys here, they're pros. I'm just some kind of like, amateur in this whole like building software thing. I'm on the machine learning infrastructure team. We mostly work with Scala. We build infrastructure for serving and scoring and training machine learning models. And so, a little bit of what build looks like at Stripe. Ruby is, we mostly use 3 languages at Stripe, Ruby, Scala, and Go. Ruby's used for the front end, which Stripe, if you don't know what we do, we process payments. We make an API for people who want to process payments. So our front end is like not only just like UI, but also like the API front end of Stripe. Most of that is handled by Ruby. Scala and Java are used by pretty much like the whole data org. So I guess if you know, like this is the Avi Bryant school of thought from Metzi, right? So like, anyways, jam as much Scala and JVM as you can when you're analyzing data. Pretty much that kind of got a toehold at Stripe. So that's kind of basically true. We don't do a mono repo at Stripe. We have a number of repos. Even in the data org, there's probably around 10 main repos. Most of those currently use Bazel now. Some of them still use SPT, which you heard about a little bit. Our largest Scala repo is about 200,000 lines of code. It's not a giant repo. It takes about 6 minutes now in Bazel for it to build in CI, which we're happy with. It's a considerable improvement over where it was with Maven. We also use Go. The Go folks do, if you're into Go, you're into like the one true way of doing things, and like the one true way, you got to do it is the mono repo. So the Go folks are into that. Like us Scala people, they don't fucking tell us what to do. If you don't want to do a mono repo, we're not going to do one, man. So anyways, here's that little bit of the Scala and Bazel history. I used to work at Twitter. And, we had our own Blaze clone there, Pants, which you might have heard of. Some people might have mentioned it. And like, actually, I really kind of did. I mean, I got a lot of dear friends on the Pants team, and like, God love them, but I really didn't like using Pants. So towards the end of my time at Twitter, we evaluated Bazel. We took a look at it, and I was really impressed with it. Some people at Twitter, I think, really like it. It's interesting to a lot of people. And so I took a look, and I found this blog post by I always say her name wrong. It's Christina, not Katrina. I always want to say Katrina. It's Christina. And she happened to use, as an example of how programmable Bazel was, this was like 2015, making a Scala rule as an example of how you could use Skylark to program Bazel. And so I was like, hey, this doesn't seem so hard. I could probably hack this thing up. So we could like make it like a real thing. I spent some pull requests over to Bazel, and they got merged, and it got better and better. And we just, we started playing with it in early 2016 when I moved to Stripe, and we were pretty happy with it. Worked a lot better than Maven, even like almost 2 years ago. And it's been just getting better and better, as you've heard some people say. So I'm going to basically tell you about like three kind of like some good parts, some bad parts, and some like, really bad parts. So let's see. The good parts. Actually, this whole reproducibility thing, like most things, like it's like, I guess it's like a lie, because like half the people who give talks like, well, we didn't do that reproducibly, and we didn't do that reproducibly. But like, I'm naive and gullible. So I was like, oh, this is going to be amazing. Everything's going to be reproducible. And actually for us, because like the Scala rules are somewhat uptight, like it has been. We've actually only had 2 cases where like something was non-reproducible, where we built it and like made some change and like, or didn't make a change and rebuilt it, and we got something different. And in both cases, those were like bugs either with Scala C, with workers, as people mentioned. Workers, since they're stateful, like something could be squirreling some state away. Scala 212, turns out it was squirreling some state away. So like problem solved. The other one was just a bug in our implementation of the Skylark rules, and when they were not completely, we didn't have sandboxing on. So it's been it works. Like it is reproducible. We have tests. It does its thing. The parallelism is like impressive, like so impressive. It basically, like with Scala, can like totally destroy your laptop, right? So you got a big repo, you like build and like let it go nuts. You're not going to be able to use that machine for a good while. So that's pretty cool. The Bazel workers, the in-memory workers, huge impact. So here's the thing with Scala is that it compiles somewhat slowly, which is cool because it's got an awesome type system and it's like doing a lot for you. So it's like, you pay more, you get more. The downside is, in order to make this tolerable, you probably want small targets. So we often operate with single file targets. So you have a lot of targets. So you combine that with spinning up a JVM every time you wanted to compile a file. Now you're several seconds of startup on all these files. It's really, really disastrous. So the workers for us made a much bigger impact, I think, even than they make for Java, because then you could have these small targets and you get them hot and they're JITted and everything's great. So that's been amazing. We've been migrated over for like over a year. Like still, we ask like surveys of like people like what's good, what's bad about like our Scala environment. Like people are like, well, like, everybody can complain, right? So there's plenty of things wrong, but that whole Bazel thing is way better than Maven, just FYI. So that was a very clear signal that still came through even a year later. So that's pretty amazing. It also helped us fix some like unsafe thing. Like once, I should probably seek help for this, but like this whole like reproducibility thing, like it's like a siren call. Like the whole world could be made reproducible, and we could like achieve this impossible dream. And like, there's some part of me just wants to like give that up, because it's like we're just like never gonna get there. But then I'm like, but maybe we can do that. But like at least some of it we actually fixed. We like all of our dependencies have SHAs and they're all checked in. It's like no bullshit now. Whereas we used to have like snapshot and like someone pushes some code over here and then all of a sudden production breaks, and like that's like, how can you live your life that way? It's like a bad idea. So what are the bad parts? So the bad parts is, in reality, like users don't really want to read the Bazel manual. So a lot of builds are cargo culted. So what that generally means is, because we want small targets, that means it's a lot of work still. So Ahir, I was thrilled to hear of all the amazing tooling he's got at Databricks that he's going to be open sourcing that, and I know Greg and people at Etsy are working on this too, to auto-generate build targets. That's something we don't have. We would love to have that. That would be amazing. The next thing is kind of very related to that. Since Scala is a slow compiler, to get good performance, we have to have really small targets. So that means, again, it's a lot of work. It's like you write your code twice. You define your imports in your file, and then you have to go and then write this manual thing over here. Of course, you don't have to do that if you just throw everything in a giant build target, and then the build performance goes to shit. But you're kind of incentivizing our users to do that because it's so manual. So that's not very good. The next thing that's painful for us, we haven't turned on what Wix has been working on with the strict dependencies. If you don't have strict dependencies, you have a tendency to add dependencies but never delete them. Like, you can't compile your code if you don't have the proper dependencies. But if you have extra dependencies, you could just have those all day. And at the end of the day, if you keep doing that, you linearize your build and you like are killing your parallelism. So that we've seen a little of that. So left to its own devices, the build tends to just slow down automatically because it gets more and more linear. Let's see. There's the main compiler for Scala is Zinc compiler. We don't use it. Well, I wouldn't say the main compiler. The main compiler backend used in SBT is the Zinc compiler. We don't use that one because it is super stateful. So it's like keeping all this state to like try to minimize rebuilds, and interact, like fusing that with Bazel's model hasn't really worked very well. So we just use Scala C, allocate a new one, which is just like some JVM program, run it on the code, and then throw it away in garbage, collect it. And as long as they're not mutating any static variables somewhere, that should be safe. Spoiler alert, in 2.12, they started mutating some static variables somewhere. But anyways, the last pain point is that we can't publish to Maven Central. We haven't tried to shave that yak. We've shaved a bunch of other yaks, and like only so many yaks deep that we can go. And so as a result of that, we still use SBT in places where we open source code or we plan to open source it, unless it's like totally Bazel related. We do have a Bazel tooling project that generates just some of the third-party generation that Ittai mentioned. Side note, I don't know if you've noticed this, like everybody working in the Scala Bazel space seems to be solving the exact same set of like 5 problems, which is kind of sad, but like, I guess we've all solved them different ways. So anyway. So what are like the really painful parts? I'll just kind of give you some headlines. Like what were the things that we didn't really like? So external repositories and dependencies, like it's kind of a bummer because it's kind of like it's really hard to like sell this thing to like a Googler. Like they have to like basically have not been at Google for very long, because their usual answer is like, just like, don't do that. Like don't have like, why don't you just like, I don't know, rewrite everything or like vendor everything. I don't know, don't do that. So even if you try to like tell them why, it's like, it's really hard conversation. So we do have a tool that works for that. So we're relatively happy with it. There's a link there. You like specify your top level dependencies, and then it generates the transitive dependencies. We check those in as build files and SHAs that like the SHAs of the jars, and that's worked pretty well. Some other people are contributing to it. It seems to be good. Hopefully we can kind of take that or other tools and like make the one true like JVM like transitive dependency generator. That would be pretty cool and not keep rebuilding. Scala, I don't know if I mentioned this, but this compiler is a little slow. So we really hope that like this build farm like story would be like really reliable and it would work with like Skylark rules by now. And it really isn't quite there. Like we're still having some bugs when we use that the worker API with remote execution. So hopefully we'll get those figured out. The Skylark APIs are pretty unstable. Like they change like quite a lot, and it's like a little bit difficult, like opaque communication as to when they might change and how they change. So, and we're starting to get some hacks in the Scala rules that does the kind of like you know, dynamic typing thing of checking to see if a method exists, and if it does, we go this path, and if it doesn't, we go another path, because we want to be able to support something other than the very latest Bazel, because not all orgs like can drop what they're doing and like port their whole build over to like, you know, Bazel 07, 08 immediately. And so, especially for a rule that is now being used by many people, like rule Scala is, we need to be able to support a little bit of a window of things. So like, it would be nice. I mean, it is good to get things in. It would be cool if we can make sure to add APIs in a way that's like easy to make sure that we have some backwards compatibility story for a little while. Last thing, one real bummer about Bazel is that it has this notion of like interface and then code, right? Which is like pretty cool, like it makes sense, but not all compiler authors were like, yeah, I should write my tool that way. And the Scala C doesn't work that way. Like Java doesn't have interface files. Like Bazel solves this in Java by this little tool called ijar, which is pretty cool. It sucks all the code out of a jar, and it just gives you a jar with the type signatures intact, and it kind of makes you have almost like an interface file in Java, which sounds pretty cool. But the problem is Scala doesn't have anything like this, and we can use ijar, but because Scala has a much more powerful type system than Java, it does that by embedding annotations in the jars that will describe those extra type, information. Now, ijar doesn't strip those out, it leaves them in, but a lot of those type system changes are not public API things. So this means when you're working in Scala and you make some change to private API that has some fancy type, or not even that fancy type, like basically any Scala type, you could trigger a recompilation that you really shouldn't be doing. And the only way that we see that we can deal with this is basically either totally re-engineer the ijar tool that totally understand Scala C, which is a total, like that is not fun. Like that's going to be a lot of work. Or if we could possibly allow, like Buck does, a way possibly for Bazel to have configurable ways of computing these hash keys. I'll talk about more of that later in lightning talks. The next thing is the CI caching, which I think we're going to have a session on. It doesn't work kind of as great as everybody talks about because the problem is, yeah, you can cache tests, but you have to go find the exact CI that ran your thing to do it. If you're sitting at home on your one machine and there's only one, yeah, caching is going to work great, but we'd have to build some system to I don't know, hash the branch name and the author and dispatch it to the right, and I don't, ain't nobody got time for that. So we didn't do that yet. Anyway, yeah, well, so hopefully we will. Hopefully we'll get there. That'll be great. So I don't know. We're really optimistic about Bazel. We're still kind of pretty much all in. It's pretty much the main candidate for a one true build system at Stripe. We haven't sold the Ruby folks that they need a build system, though we heard some talks earlier today that you have that. And hopefully that's going to happen. We did sell them. Amazing. One of my colleagues in the back there, John Milliken, who apparently we've sold them on it. So that's going to be great. So there's going to be one big thing. We use a lot of Python and machine learning because data scientists just love the Python. And we're starting to Bazelify that. We're still seeing some pain. Just want to plug for anybody at Google or elsewhere who is wants to make the Python stuff reproducible. That would be amazing because aforementioned OCD about reproducibility, I just don't even want to check in the rules Python until we can get them reproducible. I don't know if I'll sleep at night, so we're just not doing that. So that's about it.